We are going to be continuing on with chapter 1, and today is an important lesson on all the various properties of real numbers that we use frequently in math, but we kind of take for granted in terms of our ability to use these properties and not really appreciate what they can do for us in terms of solving equations and then evaluating various different math expressions. So in your textbook, you'll see a chart that's really neat in terms of all the different properties that we use with real numbers, and part of your assignment will be to take that chart and then make flashcards of them so that you're familiar with the different properties that you see. So the first part that it starts off with is what's called the properties of equality. So things that maintain equality or maintain equal or balance. Like something is equal to another value, that means they share an equal value to it. Utilize these four different properties. The reflexive property, which says any number is equal to itself, like 5 is equal to 5, 4 plus 7 is equal to 4 plus 7. Reflexive. Symmetric, if 8 is equal to 2 plus 6, then, well, 2 plus 6 is also equal to 8. You can symmetrically move them across the equal sign. Transitive property says if A is equal to B and B is equal to C, then it follows that A is also equal to C. You think of transit like transition or transportation. It moves through. Right? The substitution property, a quantity may be substituted for an equal in the expression. Like 4 plus 7 is equal to 11. So you can substitute that value, so forth. And then as we move down the chart, two important properties in addition: the additive identity property, which says if you add 0 to any value, it's itself. So 2 plus 0 is 2, and 0 plus 2 is 2. And the additive inverse, which we talked about previously in pre-algebra. The additive inverse really allows us to do subtraction. Remember, there's no such thing as subtraction. What you're really doing in subtraction world is adding its inverse. So when we have something like, for example, in subtraction, when we say 7 subtract 3, it's really 7 plus, this becomes a plus sign, and then the opposite or the additive inverse of 3 is negative 3, and that's how we get the value of 4. Again, the additive inverse allows us to do subtraction. Other properties that we encounter in math, in terms of multiplication, three important properties. Similar to the addition style, the multiple identity. So instead of adding 0 in addition world, well, if you multiply by 1, you get the same value back. Multiplicative property of 0 says that if you multiply any value by 0, you get 0 back. And then the multiplicative inverse, similar to the additive inverse, really allows us to do division. There really is no such thing as division. For example, when we say the value of 8 divided by 2, what we're really doing is the multiplicative inverse. So this becomes 8, instead of multiplication, that doesn't exist, we say it's times, and then when we say the multiplicative inverse of a value, it means this. So if this is 2, which means for us really the fraction 2 over 1, its multiplicative inverse is 1 over 2. So again, whenever you do division, it's really a multiplication problem with its inverse or its reciprocal value, if you want to call it that, is really what that is. So when we say 8 times 1/2, or 1/2 of 8, mathematically it's 8 over 2, which reduces to 4. And that's why 8 divided by 2 is equal to 4. It allows for this division to take place, which really happening or going on behind the scenes is its multiplicative inverse. And that would be true of anything that we do. If we wanted to do 12 divided by 4/3, well, this really means to us 12 times the multiplicative inverse of 4/3 is 3/4. Right? And then this is 12 over 1, so we get 36 over 4, or 9 as our value. Again, it makes division take place. And you've probably heard that when you divide in fractions in elementary school, you really change it to a multiplication and flip or take the reciprocal of the second value. What you're really doing there is the multiplicative inverse. All right, so those are the properties of math in terms of what we look at. A couple more important properties that we use in terms of expressions or solving equations is what's called the commutative property. You are allowed to commute values around. In addition, you can say 4 plus 8 is the same as 8 plus 4, and the same thing is in multiplication. You're allowed to multiply in any order. That's only true for multiplication and addition. You may not, again, you may not subtract in any order that you want, nor can you divide in any order that you want. 3 minus 2 is not equal to the 2 minus 3 idea. They are very different, so you cannot commute in subtraction. And then lastly, the associative property. You may group together values that are being added together in any grouping that you wish. Notice again, it only applies to addition and multiplication. You cannot group together subtraction of values as you wish. So anything that's being added together, you can group together accordingly, or multiplied, you may group together accordingly, but you cannot do that with division or subtraction. Alright, so we're going to look at some examples today in the textbook of what you'll be doing to practice these properties. Again, one of the assignments that you're going to be asked to do is first make flashcards for these different properties so you can be very familiar with them. And then what we'll be doing, and usually what you do are asked of when you're dealing with property work in algebra, is some of the following problems like this. So I'll give you a moment to to copy that down. Go ahead and pause if you need to. And then from there, what we're going to do is go ahead and name the property that we see displayed in this. And we'll say, well, the very first thing that they do here is, if you notice from this line to this line, they did 4 times 2. They replaced that with 8. So we say that's the substitution property. And you can abbreviate for short, SUB. We substituted values that are equivalent to each other. And then the next step, 2 times 3 plus 0. What they did was the math here of 8 minus 8. Remember that for us is the additive inverse. That's the property used there. Because again, we got 0 together as a value. And then over here, well, they did the 2 times 3 plus 0, so that part got the 6 value. Again, that's a substitution. We're substituting equivalent values to each other. And then lastly, 6 plus 0 gave us 6. That is the additive identity. So notice how I abbreviate this with those abbreviations. It just makes it go faster when you do the properties using each step. Alright, let's look at another example of what that would look like. So here's a little bit more involved example, but nonetheless kind of similar to what we've been doing. I'll give you a minute to hit the space bar to pause and copy the problem down. Alright, and then we'll go ahead and walk through this. So if we look at this problem, again, from the first step to the second step, 15 divided by 3, that's equal to 5. So what they worked on there in terms of that value, that's again substitution. And then from the next step to this line here, second to the third line, 5 minus 5 gave us 0. Again, that is the additive inverse idea. And then over here, they did 7 times 1/7 gives us a value of 1. That for us is another substitution. They substitute one value for another. 6 times 0 is 0. That's the multiplicative 0 property. And then 1 plus 0 is 1. That is the additive identity property that allows us to have that final solution. So again, these are the properties we've described given the problem to us. Alright, the very last type of problem that you're going to encounter today will be something like this, in which they are going to ask us to name the property that we use in each step. There's many different ways for you to solve these or evaluate them, but as you do this, your job is to copy each step down carefully and then name the property that you use to make that happen. So when I see something like, we'll do this 3A deal here first. Anytime I see a decimal value and the number 10 or anything that ends in 0, I want to group those together, or move them together rather. So I'll do 2.9 times 10 times 4, right? So that's the commutative property of multiplication. And we can abbreviate it like that. So I just say comm times commutative property of multiplication. The next thing is I'm going to group those together. So that's the associative property of multiplication. I can associate them together. And then I will go ahead and actually do the math of 2.9 times 10. The reason I do that is when I multiply with decimals, I just need to move the decimal point over one to the right, so it's 29 times 4. This is the substitution property, so I can substitute equivalent values. And then lastly, 29 times 4 is, well, 4 times 20 is 80, plus 36 is 116. Lastly, that's the substitution property that lets me do that. Alright, we'll go ahead and work 3B. Move it over this way. Let's slide this over. Again, I notice a fraction of 5/3 and I see a number 3. So my first move here is I want to move those right next to each other. Times 25 times 2. And again, that allows me to do that because of the commutative property of multiplication. And then I'm going to group those together. 5/3 times 3 times 25 times 2. And you know what? I'm going to pair those together as well, like this. Okay. And that allows me to do that because of the associative property of multiplication. And then here, this is 3 over 1. Any fraction is over 1, whole number rather. 5/3 times 3 over 1, the 3's can cancel, so it left me with 5 times 25 times 2 is 50. I'm going to do that one step. This is called the substitution property. I'm substituting equivalent values. And then lastly, 5 times 50 is 250. I use the substitution property one last time to get those two values put together. Again, there's many different ways for you to solve these problems. This is how I chose to organize the values and the properties that I use to do that. It's up to you to how you want to organize it, but you have to, again, justify it with the properties that we looked at. Alright, that's all for today.